Namaste. Welcome to AI Probably. I am Akshita Sharma, your instructor for the course of Data Science and Machine Learning series. In today's video, we'll be looking at the following topics. We'll go through what are pandas, an introduction to machine learning, data sourcing, and then we'll move on to data structures and pandas, where we'll be looking at how to create a data set, the types of data structures as series, data frame, and panel, and operations to perform on these data structures. Then we move on to the cleansing of data set. Then finally, we'll be walking through a brief demo on how do we apply these operations on a given real-time data set. After completing this module, you will be able to define machine learning in pandas. Know the sources from where the data is collected, create data frames, classify them, assign values, and perform functions on them. Replace the data set, create a new column in your data set, slice the data, select a certain data set, and clean the data set. Let's first look at what are pandas. What comes to your mind when you first hear of pandas? This? No. Let me introduce you to a new set of pandas which are a data frame and are really fun to be with. Let's have a history of how the panda data frame was developed and by who and what is it now. Panda is a high-performance open-source library for data analysis in Python which was developed by Wes McKinney in 2008. It has now become one of the standard library for data analysis in Python. It has been developed over the years and has been built over by 200 plus contributors over 900 plus commits by 2014 itself. And many more changes are taking place over the years. What are the key features of pandas? First of its being its ability to process a variety of data set through the various formats, let it be tabular, heterogeneous, or matrix. The available option for data sourcing from various areas like CSV, big data, or database. It can also perform a variety of operations on various data sets, ranging from filtering to reshaping the data. We can also deal with the missing data by removing it or replacing it with a certain value. It can also perform the modeling of data and statistical analysis. The most important part of a data frame is to blend well with other libraries, and pandas is a perfect fit. It has amazing performance speed as well. Panda has a benefit over the other programming languages like Java, C, and C++ for data analysis, as it also allows data representation in the best possible way and in the most concise manner. We also have data subsetting and filtering, which produces a data that is a staple of data analysis. Concise and clear code API, which allows the user to focus more on the goal, that is analysis of data, rather than write large amount of code in order to perform the task. While reading a CSV file, we can just write down 2 lines of code, which would be more preferable than writing a bulk amount of code as compared to Java. Let's have a brief introduction to what machine learning is. Machine learning is an application of AI, artificial intelligence, that provides the system with the ability to automatically learn and improve from experience without being explicitly programmed. It can be said that machine learning can be classified as supervised learning and unsupervised learning and reinforcement learning as well. Let's have a look at supervised learning. Supervised is when we train the machine using a certain data set to produce an output from them. When unsupervised, we have the input data with no corresponding output variable. The process followed by machine learning is pretty simple. Most of the data is sourced from relational database or from big data and CSV as well from separated platforms. And then we have data cleaning, where we clean the data, which is a real-time consuming process and is a part of data wrangling takes place with pandas. Then we have model building. Here in this process, the clean data is then fed to the algorithm, which further makes the most predictive features using the pattern. Prediction being the final step which tests the model on the fresh data that's collected from various other sources. Now, as we do the process, let's have a look to the first step, that is data sourcing. Data sourcing is just as its name says, source the data, that is collection of the real-time data from various sources which is used for performing various operations on the data like analysis, sorting, and so on. Now let's have a look at how this data is collected. CSV, which is an abbreviation for comma separated value. which is in the form of Excel sheets where the data is organized, structured, and really easy to work with. Then we have big data. There's a global data which is unorganized and unstructured, and it is a little difficult to work with. Well, coming down to databases are also the data where the data is sourced from relational databases like SQL and so on. Now let's have a quick demo on how do we upload a CSV file from a local drive to a Google Colab. So as I said, just 2 lines of code to read a CSV file. Once we execute this command, when it says to import Google Colab import files and then upload it is equal to files.upload, once this command is run, you will be getting a prompt where it says you have to choose a file. So, and then you browse the file. So we'll be using the movie collection dataset. Once it's uploaded and it says 100% done, we can then import Pandas as PDE. And after implementing that, we get to import. Now we have the data frame ready and we have the data set ready. All is left is we have to read the data set to the data frame. We can read it under the name of df2, and once it's done, we can then print the data frame and see the data which is read into it. So it says that we have 400 rows and 19 columns in our data set. Let's see the 19 columns along with the first 5 rows of our data set by calling the head function, which displays the first 5 rows. So here we can have a look at the first 5 rows of a data set along with the 19 columns that are included in it. In the similar way, to view the last 5 data set from your rows out of the 400 ones, we can just call the tail function, and yes, here we go. We have the last 5 data set with the 19 columns present in it. Let's now look at data structures in Pandas. Well, data structure is a method of storing the data that can be used efficiently. We can create the data by various processes, being NumPy, Python libraries, and so on. And the types of data, we have 3 types of data structures. Then we have operations on these data structures that can be performed, that are selection, sorting, merging, and so on. The main step and the most important part of all the process is cleaning the data set, which can be done by a few lines of code. Let's look at how do we create a data structure. So to create a data structure, we can manually, instead of uploading it as we did. So this can be done by 3 ways. The first one being NumPy array with access label, which is a 2D array and it's like a 2D vector. It can also be performed by defining a Python dictionary by using a structured series of array and series. Let's look at the types of data structures. The data structure can be defined as 3 types, one being series, which is a 1D array, next being the data frame, which is a 2D array, and a panel being the 3D array. Let's have a look at series and the operation on series. Series is nothing but a 1D array and consists of 1 row and various columns, or it can also consist of 1 column along with various rows. It can include integers, floats, and objects, where objects are also known as strings, but strings are called objects in the Panda data frame. So this is an example of how a series data frame would look like, which is a 1D array. The various operations that can be performed on string or series are slicing, operation and the assignment operation, and a little of few arithmetic operations as well on the 1D array. Now assignment operation can be performed by the following, and the series can be done so. So let's have a quick demo on performing slicing operation in the dataset which we have imported. First, we'll put the dataset as series by a single row and a single column, and then slice the data as between 0 and 4. So let's first import the dataset, which is one column with 19 rows. This is a series dataset. Another example of a series dataset can also be given as a collection, which can consist of one row with 19 columns. Now let's slice the data. We slice the data by DF to collection 0 to 4, which displays the first 4 dataset within the collection series. Let's hop onto the data frames. What are data frames? Data frames are two-dimensional array where the column can be heterogeneous, that it can contain an integer, string or object, boolean or float. The properties of data frame are as they have completely analogous a table to this or spreadsheet of data. The size is mutable, that is, columns can be inserted or deleted. This is an example of a 2D array or a data frame data structure in Pandas. So the Pandas data frame can be created using a dictionary and also by a 2D NumPy array, structured ND array, or another data frame. We are using a 2D array. Let's jump on to a few operations that can be performed. Let's first view on how do we display a dataset. A 2D dataset, as said, a data frame can also be displayed as this. So a head and a tail is the best example for a 2D dataset, and the dataset we have imported is a 2D dataset. Let's look at the operations on data frames now. The few operations that we perform on data frames are selection operation, where we select a specific column as a series dataset structure. Assignment operation, where we can add a new column to a dataset using this operation. Deletion, we can delete a certain set of data from the dataset using this operation. Alignment is used to align the data, including this index label. Now, let's have a quick demo on how do we perform these operations on the data frame. So, let's jump on and let's check how do we replace a data or assign a data to a certain data set. So here we see the 3D column it is given as yes or no. Let's change no to 0 and yes is equal to 1 in the Boolean data format. So when we do that, so we do df to a replace of 3D available, which says yes is equal to 1 and no is equal to 0. And once that's executed, and then we print the data frame. After printing the data frame, you can see the 3D available part changed from 1 and 0. Let's look at slicing of this operation. Well, we can also slice a 2D array, as we said in series. So when we slice a 2D array, we get 4 rows with 19 columns. Now let's perform the assignment operation, where we assign a new column to the dataset, which is called new. Performing the function using the trailer views, it performs a few arithmetic operations and stores the data within the new format. So using these trailer views, we'll be executing this command. So now here if you look down, we have a new column called new in our data set. And then let's look at how do we delete a data set. The final one being deletion, saying if we delete 3D available, you perform that and then print df2, where now the final column, which was 3D available, is not seen now. So it says we have 400 rows and 18 columns now. Well, now let's have a look at panel. A panel data set is nothing but a 3D array, and it isn't widely used as it can be visualized easily on a screen. Well, it can be easily visualized because of its 3D nature. Let's look at the three axes in the panel data structures. So the first one being the items, where each item corresponds to the data frame structure. The second one being the major axis, it displays the rows of the data frame structure, and the minor axis, which displays the columns of the data frame structure. Operations that can be performed with panel are same as series data frame, but it isn't a bit underdeveloped as most of it. Let's move on to data cleaning part now. What is data cleaning? In this process, we remove the unnecessary data or duplicated data by dropping them or either replacing them. We can also fix the missing data or the incorrect data by replacing the data set by the average of the column, also setting up a specific value to it. This can be done by isNull, where it selects or checks for the empty NaN value or the empty value. Drop NA. Drop NA, it drops the rows containing the empty value. Fill NA fills the empty value by the value specified by us. Duplicated is used to find the duplicate data. Drop duplicated drops the duplicates data in the data set. Finally, set index, which allows us to change the index column to the one we want. Now let's have a quick demo and check up if we have any duplicate data in a data set. So to perform that, we have df2.duplicated. We execute that and it says we have false, false, false. I guess this is another data set. We can check this up and see which one it would be. Okay. And after we have, it shows that it'll be the 3D data set. But 3D available is, it shows false. There's no duplicate data in it. So as there's no duplicate data out of the 400 data set we have, so we have df2.info and let's see, is there any column empty? So here we have 400, 400, 400, 400 and 392 at time taken. So here, which is 392, we can just check if does it contain any empty data or not. Like this isn't possible, so we run the function of isNull and we check for it. So we check if there is any null value present in the data set, and it says false, which means there is no null value present in the certain data set. All the data set is filled up. Now we have our data ready for the modeling process. So we can import this data to a clean CSV file which is ready for the modeling process, and we can further send it out. So we run this and now our data is stored in the clean CSV file. Now this data can be sent for the modeling process. We had a demo on the movie collection dataset. We performed, and we also have seen on how do we create a dataset or import it from a local drive. How do we display the dataset? How do we slice the dataset? And how do we even perform operations like this deleting, assignment operation, alignment operation, insertion, or assigning a new operation. Well, we also have a few more data sets imported, and then we finally check for empty value or clean the data set. And after the cleaning of the data set, it is ready for modeling, and we store it in the clean CSV file. So it's done. And got questions? Comment down below. And thank you so much for watching the video and tuning into AI Probably. Hit the like button if you enjoyed the video, and subscribe and turn the notifications on to stay updated.